Good evening. Today we are going to see how we have to decide the design bending stress in laterally unsupported beam. Laterally supported beam, it is very easy. That is directly we have Fy upon gamma m. Now in this, for this you have to see the lectures. Actually you have to go 28 and 30, which are given in playlist steel structures, and you have lecture number 28 and 30. You can go over there and you can see this. Now we will see this. So we have this section we have considered, because whatever FBD value, this FBD value is independent of the shear force or bending moment. It is property of the section. Property of section. And then tentative values we will see today, and accordingly we can consider the value and we can solve the problem. Now I have considered ISWB 600, and let length I will taken it as 3000 mm, because other we have constant one, we have change an L only for a particular section. From this we have calculated L by Ry, and then we have HF. HF we know we have HF equal to H minus TF, because it is center to center distance between the flanges. Then we now know HF upon TF. So these two values are important to calculate value of FCRB. Now if we will see formula for FCRB, we have this formula that is equal to 1.1 pi square E upon L by RYY whole square in bracket 1 plus 1 upon 20 in bracket L upon RYY divided by H upon TF whole square and to the power 0.5. And from this we will get value of FCRB. Then XLT we have lambda LT we have calculated under root of Fy upon FCRB, and then XLT we have that is 1 upon 5 LT and all, and from this we will get FBT. And for this 3000 mm we have FBT value 204.98 for ISWB 600. Then you can see in examination we cannot go in detail likewise. So how we will decide it first, that we are going to see over here. So now we know value of L upon RYY. In examination, how we will decide this? So we will calculate L upon RYY. So I have L upon RYY, that is 65. L upon RY, we have 56, sorry. Then we have HF upon TF. So we have HF upon TF. This value we have, that is 24.42. And then for this we will calculate value. We have this table, that is table 14, and this table 14 we have table 14, and this table 14 we have, that is for FCRB. Now here we have this value, that if I will say this as 25 and this is 50, if I will consider, so 50 and 25, actually we have this value. If we will go to value 60, and we have this value for L upon RYY 60, and that value we have 651, sorry, 684. We have this value as 684, that is for 60. And then 56, so I have taken, if I will take average, so I will get FCRB, that is equal to 951 plus 684 upon 2, and we will get this value 817. Tentative we are considering, and then knowing 817 you can see this. So close to 800, we can say this for 250, we have this value 206.8. And here our value comes 204.98. So you can consider tentative values, approximate values closer to the values we have, and accordingly you can decide this. That is one option. Or second option, I have considered over here, you can see ISWB, MB and LB. If 3000, then you have this value 204, 189, 179. So you can take 180 value, that is of FBD, for approximately 3000 millimeters. So for 3000, assume FBD 180. Then you can go, now I have increased span 4000, and you can see this value. Here I can say this value as 150 to 160. So 150 I will say FBD when I have span as 4000. If I will go higher side span, then you can see I can go value 130 around over here. But if you are considering ISLB sections, then you have to go on lower side. You have to keep in mind that part. So here also you have to go on lower side. Then ISLB 6 meter, if you will consider, then you have this value around 110 Newton per mm square. So for LB, you have to go little bit lower, and for MB, you can go little bit higher, or you can take these values for MB. WB, generally we are avoiding for beams. We are going to consider it only in gantry girder. Now we have considered for 6 meter same sections. So we have same section, sorry, we have same length and we have different sections. Now that you can see. So here you can see for ISLB 600, for 6 meter 89.57, for 500 it is 79.54, for 400 78.45, for 300 68.55, and for 200 56.80. So we can have values very close. You can see this, and accordingly you can consider, we can keep these values tentative in mind, and we can go for this. That is till 400 we can go for 80, and below 400, that is ISLB 400, we can go 80, and for below this we can go for 60 likewise. So I can say this, for L we have 6000, we can have value around 110. If we have L 5000, we have this value around 130. Then for 4000, we can go value 150. And then for 3000, I can go value for 180. Just we have seen in last video. So we have this value 110, 130, 150, and 180. So likewise, we have to consider these values, tentative values, and from this we can find ZP required. How we will find ZP required? MU upon FBD. That is assume. So in other problems we have considered then 1.25, and that becomes little bit critical. So instead of this, you can go for this, and for this FBD, you have to use this. If you are considering ISLB, so I can say these values you can consider for ISMB. If you will go for ISLB, then you can have little bit lower values for this. So likewise, you have to consider value of ZP, FBD, and accordingly you have to calculate ZP required, and then you can go for the section. So we have to go likewise for the FBD values, and accordingly we can have this ZP required. So now we will stop here only. Thank you.